Hello everybody. In this video we are going to discuss about Newton's laws. So are you ready? So before moving ahead, subscribe to my channel, like and share the video and keep the bell icon on so that you will get notifications regarding our new videos. So let us start. You would have noticed that when we give a sudden jerk to a blanket, then what happens? The dust particles get separated. Let me show you how it happens. So here this, so what will happen when we give a sudden jerk? You would have seen the dust particles get separated. Okay, similarly you would have also seen that, let us take a cap like this, and if you will apply a small force, then what happens? It moves away. Okay, it changes its position. But what if we will try the same with this large book? Okay, will it move? Let us try. No, it's not moving. Okay? Okay. In another case, let me tell you. Now you can see this cap is at rest here. Okay? And it is remaining at rest. But what happens when you slowly increase the height on one end of the copy? Then what happens? It starts moving. Okay? What about it? Now what makes it to move? When we increase height in one end, means when we increase the inclination of the plane. So these things we are going to discuss today in this lecture. Okay, Newton's law explains everything, what causes such kind of movement and such kind of phenomena that happen around us. Okay, so what Newton's laws are? Newton proposed three laws. Okay, Newton's laws of motion, Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. So what happened? The causative agent, according to Newton, is force. It is the force which brings motion in a rest body. It is the force which actually changes the direction of a moving body, and it is the force which brings a moving body into rest. That means what? Force is that causative agent which brings motion in a rest body and which brings a moving body into rest or helps change in the direction of a moving body. And this is what Newton's first law is. So Newton's first law gives a qualitative definition to force. Qualitative definition. Okay? First law, qualitative definition. Qualitative definition. Definition of force. Okay? First law gives the qualitative definition of force. So what first law is? Newton's first law states that a rest body continues to be at rest like this. A rest body continues to be at rest. And a moving body continues to move in a straight line path unless and until it is compelled by some external force. That means that a moving body neither changes its velocity nor changes its direction of movement unless and until it is compelled by some external force. So this is what Newton's first law is. So Newton's first law defines force as that external agent which brings movement in a rest body, which brings a moving body into rest, and which also helps in changing the direction of a moving body. Got about it? So in this way we can say that Newton's first law gives a qualitative definition of a force. Another important thing what Newton's first law tells us is what? Is inertia. Inertia is that property of a body by virtue of which a body is reluctant to change its state of motion or rest. That is called as inertia. That means what? A rest body will continue to be at rest, will tries to remain at rest only, and a moving body tries to move in a uniform velocity and in a particular direction. This property of objects is known as inertia. Inertia of objects is directly proportional to mass of the object. So here comes the explanation of the experiment that we did here. What it is? That with the application of a small force, we are able to move it. While we have to increase the magnitude of force in order to move the larger book, because this book is heavier than this cap. That means what? Heavier the object is, more is the inertia. That means we require more force to move a heavier object than that of a lighter object. So we have to remember this one is that heaviness is the measure of inertia. Heaviness, or we can say mass, is the measure of inertia. Okay. So we have learned what force is, the qualitative definition of force according to Newton's first law, and we have also learned what inertia is. So let us summarize them. According to Newton's first law, force is that external agent which brings motion in a rest body, which brings a moving body into rest, and also helps changing the direction of a moving body. So Newton's first law is this is what we can conclude from Newton's first law. But the first law is, Newton's first law states that a rest body continues to be at rest and a moving body continues to be in motion unless and until in a particular direction without changing the velocity. That means in a uniform motion unless and until it is compelled by some external force. And in this case, we came to know about an important property of objects, that is inertia. Inertia is that property of the object by virtue of which a rest body tries to be at rest only. As we have seen that this cap will remain at rest only unless and until it is compelled by some external force, like this. Similarly, a moving body tries to move. In a straight line path and in uniform motion unless and until it is compelled by some external force. So Newton's first law tells us what force is, whereas Newton's second law tells us how much the force is. Newton's second law tells us the quantity of force, whereas the first law, as we discussed, it tells us the qualitative definition of force. Yeah, definitely the question of how much it is significantly different from what it is. When we say how much force is applied in bringing a motion in an object, we can say it is the mass times the velocity, mass times the acceleration produced in the body. Let us now calculate by using Newton's second law of motion. Now what is Newton's second law of motion? Newton's second law of motion states that the rate of change of momentum in a body is directly proportional to the force applied on it and takes place along the direction of force. So what it tells? It tells two things to us. One is the rate of change of momentum is directly proportional to the force applied to it, and it also takes place. The second thing is that it tells about the direction of the force. Okay, so in what direction? It is along the direction of the force. Direction of force. So in one case it tells us that the rate of change of momentum produced in a body is directly proportional to the force applied to it. In another case, it also tells us that the force is acting, the movement is changing along the direction of application of force. Let us now find out the quantity of force applied on it by taking an example. Okay, for example, let us consider an object A having mass m. This is an object A, okay, having mass m, and which is initially at rest, okay, or initially moving. Let us consider initially it is moving with a speed u, okay, along a straight line path. Now what happened? An external force F, net force F, is applied on it along this direction. And what happened? It brought some acceleration in it. Say the acceleration is A, okay, an acceleration A is produced, and after a time t, it is observed that the object A is at y. Okay, initially it was at x, later at y, and at this moment its velocity, let us assume that v. Now what is the initial momentum here? The initial momentum is mu. Now what is the final momentum here? Final momentum, because of application of the force, mv. Now the rate of change of momentum means what? The rate of change of momentum, that can be written as momentum, that can be written as mv minus mu divided by t. Okay, now this is equal to mv minus u by t. By using the equations of motion, we can say, we know that v is equal to u plus at. This is the first equation of motion. From first equation of motion, we know this. That implies what? V minus u divided by t is equal to a. We can replace v minus u by t from this equation. Now we will get f is equal to what? Sorry, the rate of change of momentum is equal to ma. According to Newton's second law of motion, this force is directly proportional to ma. That means what? F is proportional to ma. Or we can say F is equal to kma, where k is the proportionality constant. Okay. The quantities F represents force, m represents mass, a represents acceleration, are so chosen that means they are chosen in SI units, and when they are chosen in SI units, the value of k becomes 1. As it becomes 1, we will get F is equal to ma. This is the required expression for force according to Newton's second law of motion. Hence, Newton's second law of motion tells that force is mass times acceleration produced in it. We can also find it in another way. Okay, let me erase this part. Okay. So what it is? According to Newton's second law of motion, states that rate of change of momentum is directly proportional to the force applied to it. Or we can say F is directly proportional to dp by dt. Derivative of momentum with respect to time. Okay. So here what happens? P represents momentum. Okay. And momentum means what? That is equal to mv. Let us replace the value of p in the above equation. If we replace the value of p in the above equation, we will get F is proportional to derivative of mv with respect to t. Or we can say F is equal to k derivative of mv with respect to t. The quantities are so chosen, the units of the quantities are so chosen that the value of k is 1. Okay. So value of k is equal to 1 if the quantities means what? M, V, F, all are taken in SI units. Okay. What about it when all the quantities are in SI units? Then k F is equal to k dm v by dt. Okay, that is reduced to F is equal to derivative of mv with respect to t. Or we can say force F is equal to m dv by derivative of velocity with respect to time. Why m? We have taken m out because m is constant. Mass is constant. Mass m is constant. Or we can say F is equal to in this case what we can write? ma, where derivative of velocity with respect to time is acceleration a produced in the body. So in this way also we got F is equal to ma. So Newton's second law quantifies force. Force, how much force? It is mass times the acceleration. Mass times the acceleration produced in the body. What about it? So this is force. Clear? The next thing is Newton's third law of motion. Newton's third law states that to every action there is an equal and opposite reaction. But let me tell you that action and reaction are simultaneous phenomena. Simultaneous phenomena. That means nothing like that an action will occur first, then a reaction will follow. Nothing like that. Okay, they occur together. Action and reaction occur together. Now you can say, if action and reaction are equal in magnitude and opposite in direction, and they occur simultaneously, then why they are not cancelling each other? Yeah, very good question. Definitely that we need to discuss. So let me tell you that though action and reaction are equal and opposite in nature, that means in direction it is opposite and equal in magnitude, but still they never act on the same body. And this is the reason why action and reaction, though equal and opposite, never cancel each other. In one example, say an object is placed on a table. Then what happens, this object is exerting a force on the table. Okay, this force is applied on the table. Okay, action is done on the table. This is action part, and action part is on the table. Okay, what about it? Whereas the reaction part is on the body kept on the table. So whereas this is reaction part, you can say normal reaction N or R, okay, like that, anything you can take. This is the reaction and this is action. Action is on the table, reaction is on the body. This is the reason why they are not, even though they are equal and opposite, they do not cancel each other. Newton's three laws, Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. What does the first law tells, what does the second law tells, and what is the third law all about? Okay, got about it? So in the next video there would be a question for you. Okay, so when we are talking about forces, we should also know about the balanced and unbalanced forces. Can we imagine, there are two questions for you. Okay, so can we imagine a system, or can we imagine a body without any force applied on it? Sometimes we say that, yeah, no force is applied on it. Sometimes we say. So how much correct this statement is when we say that there is no force applied on the body? Is it possible that a body can exist without application of a force? That is question number 1. Question number 2. Can we imagine a body being acted upon by only one unbalanced force? Only one force? A single force? That is also a question. Can we say that a body is being acted upon by only one force? That is another question. And the third question is that what happens when a system of bodies are connected together? How the forces react with each other? How the forces act together in that condition? And what happens when multiple forces act at one point? These questions we will discuss in the next video, but don't forget to comment the answers in the comment box. Okay? Thank you.